Well, happy Friday and good morning, geometry students. Or I should say, good afternoon to some of you geometry students. Or I should say, good evening, some of you geometry students. Some of you are watching these videos at the 11th hour, doing this stuff late at night, which, as long as you're getting your homework in before midnight, I don't care. Whatever works with you. Me personally, I'd try to get it done sometime in the morning or even early afternoon, but you make that call. So welcome back, everybody. Happy Friday. Got a nice little weekend ahead of us. I'm starting off with just the answers from section 10.5, which all of you turn in your homework. Here are the answers. Check them. It's always good to see if we're doing things right. Go back, redo them if you need to. And before I start 10.6 today, we're getting closer to the end of the chapter, and I want everybody to be aware of what's happening when we get to the end of the chapter. We are having an end of the chapter quiz. So let's recap, everybody. We've already tackled 10.1, 10.2, 10.3, hence the little check marks right there. 10.4 we did Monday. 10.5 was Wednesday's lesson, and you turned it in on midnight, and you're checking those answers right here if that is of any importance to you. And then today we're going to be doing 10.6. Next Monday, I gave you 10.7. Now, if you remember a couple of videos ago, I told you, maybe you remember this, maybe you don't, but a couple of videos ago I told you that this assignment, I will not give you an assignment for 10.7. Once I teach 10.7, lesson 10.7, I'm giving you the review for this. So, on Monday, this is going to be a little different. On Monday, when you get this review guide, it is not due midnight. I don't even want it on Tuesday because, well, to be quite honest with you, we're not meeting on Tuesdays. So you have all of Monday, all of Tuesday to be working on this review. And honestly, you really have all of Wednesday to be working on the review. Because when you tune in on Wednesday, I'm going to have another quiz ready for you on Canvas. It's going to be somewhere more than 10 questions. I was playing around last time that we did this. I threw 10 questions in Canvas just to kind of see what would happen. And I think I'm going to throw a couple more at you. So you're going to be taking a quiz here, and this is when the review guide is due. So the review guide is due. I'm also going to have all of you turn in your binders. Now this is going to be kind of madness for you and for me grading it. You need to take pictures of every single section of notes and send them to my email. I know it's just kind of a hassle. I'm sorry. I guess I need to apologize. But it's 10 easy points coming your way. And I think for that, it's going to boost most of your grades. Review guide, once again, it's due next Wednesday, but I'm also going to make that a 10-point question. So just be ready for everything that's coming at you. But we really don't have to worry about all that today because I'm teaching you 10.6. So enough of me talking. Let's get started. 10.6 in your notes. Move some other papers out of here. Today I get to teach you secants and angles. Secants. S-E-C. That's a C. That's an E. S-E-C-A-N-T-S. Secants and angles. Now, what is a secant, Mr. Kosal? What is a secant? Well, I haven't really taught you what a secant is, not until, well, now. So, let's do this. I'd like you to make 3 circles. Uno, dos, trois, en français. Going from Spanish to French. Above this first circle, I'd like you to write the word chord. Above the second circle, could you write the word tangent? Now, these are 2 words that you should know, and you should know what they look like on a circle. And here's the mystery one. This is the new word of the day. Could you put secant over here? I'm going to show you what a secant looks like. All right, let's start with the easy one, a chord. I think this was 10.2, maybe 10.3, I don't know, one of those 2. A chord goes from an endpoint to an endpoint on a circle. Folks, that's a chord right there. It could be chord AB. Pretty simple, pretty easy. A chord can actually be a diameter of a circle. Let me put the center of this. Let's call this C. and make a diameter go, how about A to D? AD is also considered a chord because it goes from an endpoint to an endpoint, but it's a specific type of chord. We call it a diameter because it goes completely through the center of the circle. Chord is the easy one. Over to a tangent. Now, if you forgot what a tangent is, this is when I need to get my ruler on the screen. A tangent is when you have a line that touches a circle at how many points? I wonder if anybody actually said 1. If you're actually like watching this and you say 1, maybe not. Maybe you're all just like watching, staring. All right, a tangent line is a line that touches a circle at 1 point. So, ding, touches at 1 point. It's hard to visually draw, but we kind of get the idea. That's a tangent line, folks. And there's a huge, huge theorem that goes with tangent lines. Go ahead and make the center of the circle right there. If we connect the point of tangency, where the tangent line meets the circle, the point of tangency to the center of the circle, which is called the radius. Hopefully you remember this huge, huge theorem. A tangent line and a radius, you always have a right angle every single time. Okay, that's a chord. That's a tangent line. Let's draw a little line to that. Tangent line, chord. A secant's a new one, but it's not a hard one, folks. A secant is just a line that goes through a circle. There. Get my straight edge. Ready? Folks, I give you a secant line. That's it. That's all it is. This is a secant line. Maybe I should just draw it to the line. It sort of looks like a chord. If I were to cover up this extension right here, and if I were to cover up this extension right here, it's kind of a chord, ladies and gentlemen. But the difference between a secant and a chord is endpoint to endpoint, is a line segment, whereas a secant is a line. That's my lesson today, folks. But with this lesson, there's a couple theorems that I got to throw your way. So let's just jump into it. Flip the page. New piece of paper going. All right. Here's the first theorem that goes with secants. Now I've named it. I call it. What is this called? Oh, I call this the crisscross theorem. For obvious reasons, because we're going to have some crisscrossing going on here. I'd like you to draw a circle. Don't draw a center, please. Do not draw a center. I'd like you to draw 2 secant lines. So it really doesn't matter where they are. I'm going to draw it right there. There's secant line number 1. And let's do another secant over, once again, it really doesn't matter. It works every single time. Right there. There's secant line number 2. They're just lines that go through a circle. All right, let's go ahead and label these. Let's call this, I don't know. Let's call this A. Call that B. C, D. And then put angle 1 right here. And could you put angle 2 right there? No. Let's make it simple. Just work with angle 1 with me, folks. So obviously we got a crisscross thing going on here. We got 2 lines that are crisscrossing on the inside of the circle. Here's the crisscross theorem, folks. Pretty much says this. The measure of angle 1. So let me get my red pen out. This angle right here is going to be 1/2 of the measure of arc AB plus the measure of arc CD. That is the crisscross theorem. You may not like this, folks. You may not like this. First time I saw this a long time ago, I did not like it. It's so much easier with numbers. So let's do this. Let's go ahead and give an angle measure for arc CD, and let's go ahead and give an angle measure for arc AB. So AB, let's see, this one looks bigger than that one, so let's say this is 110 degrees. I'm just picking a number out of thin air, folks. 110 degrees. We're going to say this angle right here is, I don't know. How about, I'm trying to work with something. How about 50 degrees? Yeah, Yeah, we're going to say that's 50 degrees. If you want to find the measure of this angle right here, the measure of angle 1, it's going to be, all right, let's throw some numbers in. Measure of angle 1 is going to be 1/2. Measure of arc AB, well, that's 110. Plus measure of CD, that's 50. Okay, so the measure of angle 1 is going to be, okay, I can add these two together. 110 plus 50 is 160. And then half of 160, anybody? Oh, I wish I could hear students. It's been a long time. 80 degrees. Folks, that's an 80-degree angle right there. Like I said, crisscross theorem, once you work with it a couple times, it really kind of comes naturally. It comes fast. This angle, 80 degrees, is going to be 1/2 of these two added together. So if you add these two together, cut it in half, you get that angle. That's the crisscross theorem, folks. Let's try this.